Ready? Ready, Rufus? Okay, the difference now is that we have an angle that we're trying to find, and we got 4 of those problems here, and the right angles have to be drawn in actually. You might notice a little white dot, and those were red, and this was printed in color, and so that didn't actually show up. So do make sure that you draw those in, because that's crucial. Again, you can't use trig ratios unless it's a right triangle. So let's set this up. We're looking from here. We want to find that angle. We have 2 distances here. This is the hypotenuse because it's directly across from the right angle. And then this guy here is actually the adjacent to the angle. And here we are with sine again, an A and an H. So this means that the sine of theta has to equal, I said sine, that's cosine over 13.9 over 16. Okay, so then what I am going to do is I'm going to undo the cosine theta and get theta by itself by taking the inverse cosine. Sometimes it's called the arc sine. Those are really the only 2 names that you want to use for it. You don't want to call it cosine -1, or even if you said second cosine, I know what you mean in a calculator. In fact, I say that sometimes. But you do want to say inverse cosine or arc cosine, okay? It's not even a reciprocal. Don't call it reciprocal cosine, because that's not actually it, because reciprocal cosine is actually secant. All right, so anyways, we've got this. We're going to then just take the inverse cosine of 13.9 divided by 16. That's going to be 29.7 degrees. All right. Over here, we're looking from this angle, and we find that this is the O, and that is the H. So we're looking for sine. The sine of theta equals that O, which is 8 over 16. That's a half. Okay, now I actually know that the sine of half, I know that from the unit circle, because half is a really nice sine value. That's actually 30 degrees. Okay, but let's say that you forgot. All right, let's go ahead and just do what we would normally do. All right, you can see that that's going to take us right to the unit circle, and that's 1 divided by 2. All right, 30 degrees. All right, so now we're just going to draw a diagram, and we've got, we want to find out B. Okay, so there's C. This is B, I guess, and we'll just make sure that we'll call that theta, or capital B. It actually doesn't matter. We could still call it capital B. I like using theta just because it's such a commonplace thing. I should have maybe perhaps called that capital A. It didn't matter. So I'll call it capital B just to show you that you can't change it up, and it's just pretty much trivial. This is lowercase c, and then that's 15. Now, since I don't have c, I could easily find that out, but why bother? Why don't I just go ahead and just use what I have? This is the O, and that is the A. So that makes for a tangent. So the tangent of B equals 8 over 15. All right, so I will take the arctangent of 8 over 15. All right, so arctangent of 8 divided by 15 is 28.1. Okay. And then over here, let's see, we're going to draw this guy with C being the right angle. So that makes a lowercase c the hypotenuse. So that's H. And then B we'll just make here. And we want to find capital B. So it looks like we have the O and the H as knowables. So we want to say that the sine of B. Now, oh yeah, no, I was going to say something. Okay, so the sine of B has to equal that. You know what to do. You do the second sine of 4.2 divided by 10, and you got 24.8. Okay, and that's D. All right, so now we're getting into tier to where we at. 4, oh, that's it. Good. Now we're getting into the non-right. Oh, that is 90 degrees. That's 90 degrees. All right, I could actually use a trig ratio there. That's kind of cool. That was luck. So we're going to use a trig ratio for that. But this one, no. This is an obtuse triangle, so this means that we're going to have to use a law of sines or the law of cosines. So let's see what we got. We have an angle side angle, so that is a law of sines. But the problem is that the law of sines, the 26 is actually related to this capital B. This is a lowercase b. So what I'm going to have to do is I'm going to have to do just a little extra step and figure out what that capital B angle is. Now I've got the other two, so all I got to do is subtract from 180, and that actually gives me my capital B. So this is 39, and that's actually important because now I've got a sine of B over 26, okay? Or what maybe I should say 26 over the sine of 39. All right, I need that because I have to have a complete ratio in order for me to use the law of sines. Now I want to find BC, so I'm looking at this guy over here. I'm going to call that X. Okay, I want that segment, and he is related to the 14 capital A angle, 14-degree angle. So this means that it's X over the sine of 14. So remember, I'm keeping the angles parallel with each other, and I'm keeping the side lengths parallel with each other. That's important. We could have flipped these over. It just doesn't matter. Now what I'm going to do to get X by itself is multiply both sides by the sine of 14. So what I've got, what are you complaining about? I just fed you. Sine of 14 degrees. Go away. Okay, so that's the law of sines there. That's as complicated as it gets. We're going to go 26 times the sine of 14 divided by the sine of 39. The cat is so pushy. All right, that's even 10 kilometers. All right, 7-minute mark. That's 90 degrees. Why bother using the law of sine? Let's just use what we have. We want to find BC, that is the hypotenuse. And it is the hypotenuse because that's 90 degrees, okay? Over here, there is no hypotenuse. There's the longest side, but it's not the hypotenuse. So we're looking for the hypotenuse, and we have this guy, and we have this would be O from this perspective. So the sine of 76 degrees equals the O over the H, which I guess we'll just leave as a capital H. And we want to solve for that. And here is where we kind of do the switcheroo. Okay, doing two algebra steps in one. I'm going to find out what 32 divided by the sine of 76 is. That's 32 points. That's basically 33 once you round it up. So there we go. All right, moving forward, we're at the 8-minute mark. 2 minutes to do two problems here. All right, we've got this guy. We have a side, so this is a side angle. So that is a law of sines. Okay, and I'm looking for capital A. That's perfect. So this means that these guys are paired up and these guys are paired up. All right. So this means that since I'm looking for an angle, I guess I might as well just put the sines on the top. I never used to really care about this, but I find that it's actually easier if you're looking for an angle, put the sines on the top. It's actually a little bit easier to explain. 15 is connected to this, and then 13 is connected to that, because now all I'm doing is I'm just moving the 13 over to the other side. I don't have to switch things. Okay, I find that just a little bit, I don't know, just a little user-friendly. All right, so what that's going to produce is it's going to produce the wrong answer. And what I mean by that is you are going to possibly be confident that you did it right and think that that is the correct answer, but it actually isn't, because that is the sine. And the sine, remember, is a percentage of the actual angle. okay? With 90 being 100%, this is 86.6% of that. No, that's not true. No, oh my gosh, scratch the last 10 seconds of what I just said. That's mathematically erroneous. So I want to find the sine inverse of 0.866, and I do believe that is 60 degrees because that is one of those nice round numbers. Yep, 60 degrees there. Okay, that's A. And then finally with this one, I'm trying to find this guy, angle C. All right, so that guy's paired up here, and that 103 has, that 103 has to be here. It cannot be there. That is an acute angle. This is an obtuse angle. So these guys are already paired up, and these guys are paired up. So this is actually a nice setup for us here. So the sine of 103 over 26. Okay, so now you'll notice that if I'm going to multiply both sides by 6. All right, and then I would actually take the inverse sine. So I can actually write it like this, even if I wanted to, and dump the whole thing in the calculator as long as I type it in is exactly as it should be. So let's go second sine, and what I'll do is I'll remind you how to get the fraction bar, which is alpha y equals, okay, and it's number 1. It'll produce that fraction bar. Why not? If it's going to help you reduce your errors a little bit, why not? 26, push that over, close up those parentheses. That is exactly as it is on my paper. All right, and so we've got 13. 13 degrees is the actual angle for C, okay? And that does appeal to my common sense. So, 12-minute mark, dang, stop it.